Hello everybody, Steve Matthews here, and today we're going to talk about field rotation and its errors. I can be found on YouTube under Teeth of the Lamb, all one word, or on Facebook just under Steve Matthews. If you've been following my videos, you would know that I've been filming the moon recently and looking at the rotation, the clockwise rotation of the moon throughout the day. I've been trying to fit the rotation of the moon into the heliocentric model and, using all of their distances and rotations, and quite frankly, I just can't seem to fit it into that. And the problem is that if you have an object that is 2,159 miles wide, in orbit 239,000 miles away, you just quite simply don't have a big enough arch to create field rotation. The face of the moon will exhibit about a 180-degree turn in one day. Now think about this for just a moment. To get a half a turn, 180 degrees on that moon, you have to have a very drastic arch across from horizon to horizon. And there just simply isn't enough at 239,000 miles away. The radius of orbit is so large at 239,000 miles that it would be practically imperceivable to have any kind of rotation on that moon, anything visible anyway. So I figured there must be something that I don't understand or know about field rotation. So I went online, watched a number of YouTube videos on the topic, lectures and stuff, college level, and it became apparent real quick what the problem was. And simply put, they've gone too far. They've made everything, their wild, fantastical millions and billions of miles, is just simply too big to support any form of arch whatsoever. So they have to pull everything back, right back to the dome. Okay, so let's think about this again. They like to push this that you can't see the curvature of the Earth because it's just simply too big. Okay, let's take this. Our nearest star is Alpha Centauri A and B. It's a set of stars, and you've got that at 4.3 light years away. To put that into perspective, that's light traveling at 186,282 miles per second for 4.3 years. Now the problem is the heliocentric model would dictate that you have to draw your orbit at that 4.3 light years away. And they just simply can't do that because they won't have any arch, and it's unexplainable. So they have to pull everything back to a very close proximity to the Earth. And it would be just like God said, that he put the sun and the moon and the stars in the firmament right over our heads. And that's exactly where they have to place them. And they spend a lot of time trying to justify that. Well, we can't tell how far things are away, and we have to do a lot of tricks to get our distances. No, the sun, the moon, and the stars are not far away, and there is nothing that is obvious that says that they are, except one set of people. And that group of people would be the heliocentric cult of scientism. The same group of people that would be all too eager to point out that our forefathers were morons because they thought the Earth was stationary and flat with a dome over it. And all the stars, the sun, and the moon were placed in that. So they built their house of cards on lies and deceit, with placing everything millions and billions of miles away, and they're oh so clever. But the real funny part of all that is that they've had to take the work that was built on the backs of those morons, and they had to plagiarize it and use it for their own, because those distances just absolutely do not work in field rotation. So you have to pull them back. You have to pull them right back to the dome where God said it was. And that's my point. The distances used by heliocentrists is impossible to create any form of arch that's steep enough to give you field rotation. They like to do this distance game with everybody, where they change the distance real far away at their convenience, and they pull everything way back at their convenience, and everybody's just supposed to buy it. But you know, those distances are, in an equation, the biggest part of it, and you can't ignore it, and you can't get by with just saying, oh, well, we just can't perceive those distances. Well, you have to be able to perceive them, because you can draw a circle that's a straight line, and that's what you'd end up having, and you wouldn't see any field rotation. So don't let them keep playing this game with everybody. They did this during the total solar eclipse of 2017, where they pulled the sun 400 times closer to create a penumbra with the moon. Don't let them do that to you. When I was doing my brush up on field rotation, I watched a number of videos, and I took some clips out of those, and I'd like to show those to you. We'll have a little fun. Listen real carefully to their terminology and what they say, because it's pretty revealing, and actually I got quite a few laughs out of it. So I'm just going to let these play out for you, and I think you're going to enjoy it. Now pay attention, because they keep saying that our forefathers believed that there was a crystal sphere around the Earth. And that's not true. They believed there's a crystal dome over the Earth, and that's exactly what they have to portray here. And you're going to find that real interesting. One big proof video floating around on the internet is where they have the Blue Angels, and they fly directly overhead at a low altitude, and they film it, and then they take 3 or 4 different photographs, one before it reaches them and one above and one afterward, and it shows rotation. The red, white, and blue contrails are pointed in different directions, showing that it's rotating. But this is my whole point. That's possible when you have something close at hand, but not when you have something distant and far, because you don't have enough arch. And that's the whole point of this. These clips are under fair use for commentary, critique, and review, and discussion.
Hello ladies and gentlemen, and welcome back. I'm Mr. Stano, your Earth Science teacher, and today we're going to talk a little bit about the celestial sphere. The celestial sphere is the backdrop that everything appears in either the nighttime or the daytime sky. If you take a look, we have this little gentleman right here looking through a telescope, and all the stars appear to be on this right here, this dome that surrounds us. There's a couple of components. You can see that he stands in the middle. The observer always stands in the middle of their celestial sphere.
The celestial sphere is an imaginary sphere surrounding the Earth, onto which are projected the objects of the night sky.
How the sky moves. Look up on a clear night and you'll notice that the sky looks like a vast dome with stars fixed to its inner surface. The Earth spins in space, rotating once a day on its axis. But from an observer's point of view, the Earth appears to remain still, while the celestial sphere seems to rotate once a day around an axis that runs from the north celestial pole to the south celestial pole.
Okay, so this is a model of the celestial sphere, and it's really hard to get an idea of what's going on without seeing it, and I can't even tell you if this is showing up with the camera because I covered up the video because I can't stand to see myself. Just to let you know. So the goal of the celestial sphere is to somehow picture the sky, and in this model, it represents all the stars as being on this shell surrounding the Earth. Now, clearly, that's not the way it really is.
Since the planets in our solar system orbit our star largely on the same plane as each other, kind of like a giant pizza with the sun in the middle, the path of the moon and planets in the sky closely follows this line of the sun.
Celestial sphere typically is shown as a clear globe, plastic or glass, and the Earth is at the center, and the stars, sun, moon are all about the sphere as we see them in their constellations. Of course, this is not real. It's only convenient. It's a convenient way to talk about the sky.
This video, taken from a mountaintop in Chile, where some of the world's largest telescopes reside, shows this motion of the sky, but time has been sped up. At these speeds, and with a little imagination, it is easier to think of ourselves as passengers on spaceship Earth, spinning against the background of fixed stars. In general, though, our senses make it hard to accept that the Earth is moving at all, and we are moving very fast. At the latitude of Tucson, we're moving at 880 miles per hour. But we just don't sense any apparent motion. In fact, as you will see in a later lesson, it wasn't until recently that the notion of a rotating Earth became commonly accepted. It's much easier for us to instead imagine the entire sky rotating around us, since that is what we observe with our senses. We see the sun rising and setting, and stars moving across the sky. Because the Earth is a sphere, we represent the sky as a celestial sphere surrounding the Earth.
Okay, well, going back to this idea of the celestial sphere, let's start by taking the Earth's poles and projecting them onto the sky, and that gives us the north and south celestial poles. And we'll take the Earth's equator and project that onto the sky, giving us the celestial equator. So this, in total, is the celestial sphere. Now, we know today that, no, the stars are not really imprinted on an actual sphere, but it's a useful fiction. It allows us to identify not only the positions of stars in the sky, but to help us understand their apparent motion around us.
Celestial sphere. Well, as an observer on Earth, if you look at the night sky, you will see that it appears as a huge dome or sort of inverted hemisphere.
Now, we've talked about this already in class, but what I wanted to talk about also is that yellow sphere that's inside of here. That's really where we left off. Now, that turns out to be a model of the sun. And we know that the sun is much bigger than the Earth, but in this particular model, it's actually quite small. I mean, after all, when you look at the sun in the sky, you can put the sun behind your finger. So its angular size is actually quite small. It's a big object, but very far away, obviously.
I have to make commentary here. There's nothing obvious. I see a small, close sun, and nothing is obvious about a sun 1,300,000 times the size of the Earth, or 93 million miles away. Nothing obvious at all.
It's based upon our lack of understanding of distance. Like when you look up at the sky at night, can you see how far the stars are from us? No. We have no idea how far they're away.
Excuse me? We have no idea how far the stars are away? NASA has a distance to everything, even the weight. Hey everybody, listen real carefully to all of the excuses they're given for this field rotation.
Distance is the hardest thing to measure in astronomy. We have to use all sorts of tricks to figure out distances. Just looking at the sky, we have no comprehension of distance, or that some stars are farther away than others. They all appear to be kind of at the same distance. In fact, this is what the ancient models, cosmological models, assume. The ancient models assume Earth is sitting here at the center, and then around it there is a sphere. They didn't think of the stars as distributed through three-dimensional space. They thought there was a sphere that enclosed the Earth. They call it the celestial sphere. But imagine the sphere encircling the Earth, and you can do that. Since we can't see distance, we can pretend they're all at the same distance, painted onto this sphere. And back then they thought the Earth was standing still, and the sphere would actually go around the Earth. The whole universe would go around us. Nowadays we know that, under the idea of the sphere, the universe is out there, and we're rotating underneath it. Makes the appearance of motion of these stars.
In this video, we'll explain the coordinate systems used in celestial navigation. Every location on our planet has a unique set of terrestrial coordinates consisting of latitude and longitude. These are more commonly referred to as geographic coordinates. Let's assume our planet is a perfect sphere.
The celestial sphere is the imaginary crystalline sphere on which all of the stars exist. The Earth is the center of the celestial sphere. So we get this idea back from the Greek times when they actually used to think that stars are on a crystal sphere.
Actually, they never thought it was a crystal sphere, but thought it was a dome. Our forefathers knew about a flat Earth and a dome.
Okay, but of course now we know that that's not true. Stars, no matter how distant, they are pictured as being on a single crystal sphere. So bring them down, and then now state where are they located on that sphere, you see? So even though the concept of a sphere, a crystal sphere is not true, as a scientific model, it's still a helpful model to write down where stars are in the sky and how they travel in the sky. So it's a good scientific model.
This model explained why all the celestial objects moved in the same direction at the same speed. It also explained why the stars remained in fixed positions relative to one another. The Earth-centered or geocentric model of the universe was used successfully for thousands of years to explain most of the observations of celestial objects. Even though we now know that the motion of celestial objects is due to Earth's rotation, it is still sometimes useful when discussing objects in the sky to think of them as part of a sphere surrounding the Earth. The most that an observer would see at any one time would be half of this sphere, but we still refer to this imaginary half sphere or dome visible over our heads as the celestial sphere, even though we know better.
On the celestial sphere.
Okay, before we show you how to find the North Star, let's point out a few things. First things first, this is not how, all the stars are not actually on a sphere around the Earth.
Greetings and welcome to the Introduction to Astronomy. In this section we will talk about the celestial sphere, and that is really what you see when you go out at night or during the day and look up at the sky. It looks like the universe is a great sphere surrounding the Earth, and that is what ancient astronomers would have believed. And when we look out at it, it still looks like everything is stuck on this great celestial sphere because we don't see the three-dimensional nature of the universe. You can't tell when you look at various stars whether they are close or far away. There are measurements that astronomers can do to tell that, but in reality what everything looks like is like it's hanging on this great celestial sphere that we will talk about today, because we still use that for determining locations of objects on the sky. So what is the celestial sphere? Celestial sphere is a way of visualizing the sky. So it is a way that we're able to see what there is in the sky, and it is a geocentric model. What that means is that we are looking at it from an Earth-centered point of view. So that is Earth-centered here. That we are looking at it is essentially, we consider it Earth-centered. Now we know that's not correct.
Let's assume our planet is a perfect sphere.
But it still works for determining positions in the sky because it acts as though we are at the center of this great sphere.
Let's assume our planet is a perfect sphere. Let's assume our planet is a perfect sphere.
And all of the stars, all of the planets, all of the other objects that we see, things like galaxies, all appear to be positioned at various points on the celestial sphere. The planets, the name comes from wanderer, so they are wanderers. They wandered among the stars and moved through the stars. So in the image here, you can see that the planet here is moving through Capricorn and then moves into Aquarius. It makes a little loop and then it comes back and heads into Pisces. This is what we call retrograde motion. This little loop, this is something that is distinct to the planets only. So only planets will undergo retrograde motion. The sun and the moon do not do this. They move through the sky just like this. They go through those constellations, but they just make a completely straight path. The planets will at specific times form this little loop, which was very important for our understanding of the motions of the planets.
They begin to figure out all of these things. Let's take a moment now to see what they saw. Objects have shifted their positions slightly, but apart from that, our ancestors saw thousands of stars that seemed to be fixed on some celestial dome or sphere, slowly rotating around us. They kept track of their positions.
This is real brief, but I wanted to include it in case you're interested. I found the Coriolis force interesting because he's actually saying it's detectable. And, you know, we've all seen those pictures of the rocks piled up in the creeks and stuff. I don't know. Interesting.
So, if the stars are moving from east to west, I mean, we got two possibilities. The Earth is sitting here, and the whole universe is rotating around us. Sounds crazy, but that's what they believed for thousands of years. That's the ancient Greek model. Or the stars are out there and Earth is just spinning on its axis. And we all now know in the modern day that's the case. But back in ancient times, ancient Greek times, it was a reasonable idea to think that the Earth is stationary. I mean, if you're on a merry-go-round, you feel the rotation, right? You want to be thrown kind of to the outside. Or if you're on a track driving your car or some vehicle, you're kind of pushed to the outside. Do you feel Earth's rotation? No, you don't really feel it. But there is a force. It's called, you do have the same kind of feeling. You are being pushed slightly to the west, I think it is. It's called the Coriolis force, and we'll talk more about it in Lesson 2. But if you crunch the numbers, the size of the Earth, and the rate at which it's spinning, the force that's inferred from that, it's small compared to the force of gravity. So gravity is our attraction to the center of the planet, all the masses beneath our feet. Gravity is an attraction between masses. So we have this pretty sizable force pulling us down. So we don't really notice the small force pushing us to the side, the Coriolis force.
Just to highlight some of the things we've talked about here today, the field rotation requires pulling all of the stars, sun, and the moon within a real close proximity sphere. And they have to do that because if they use the actual distances, the arc of the moon and of the sun and of the stars would be so large that you wouldn't see any arc or field rotation, because that's what causes the field rotation. They'll start saying that they can't tell the distances to the stars, and they'll say that it's all an illusion, that you couldn't perceive the distances, so they have to pull them real close. That's their excuses, but there's a dome over this Earth, and they had to put those stars and the moon and the sun right back where God put them, where he's to cover their lie. They can't account for the great arc that it takes to rotate the moon and the stars as much as they do without making them real close. Thank you for watching, and you all have a darn nice day. And if you like anything we've heard here today, subscribe and like, or not. Thank you.